Hello students, welcome to another session of online class. So today we are solving some numerical problems related to divergence. So moving to what we have learnt in the last class, we have studied about what is divergence. So divergence is nothing but total outflow of flux from a unit volume as the volume shrinks to 0. It is limit delta V tends to 0, closed integral d dot ds by delta V, or closed integral dot d dot ds is nothing but the charge enclosed, so it will be rho v, right. So we also discussed about there is a new operator called the del is dou by dou x plus ax cap plus dou by dou y ay cap, like that. So that is also equal to rho v is the volume charge density. Also this is called Maxwell's equation in point form, Maxwell's first equation. Okay, and the same from this one we got the closed integral d dot d is equal to volume integral del dot d with dv. So this is also called divergence theorem, and it's the Maxwell's first equation in integral form. Okay, so how to find the del dot d in different coordinate systems? So we have seen the general equation 1 by h1 h2 h3 dou by dou u h2 h3 du plus dou by dou v h1 h3 dv plus dou by dou w h1 h2 dw. Also we have discussed about what is the general coordinate system where u v w. For Cartesian it will be x y z, and h1 h2 h3 will be 1 1 each. For cylindrical we have discussed that for u it will be rho phi z. Since rho is a distance 1, phi is an angle, so we have to multiply it with the radius, so rho here, z is a length, so again 1. For spherical coordinate system it is r, theta and phi. So r is a radius, so 1, length, so 1, theta is an angle, so the radius is r, phi, the radius is rho is equal to r sin theta, so it will be r sin theta. So these are the values we have discussed in the last class. So moving to a problem. So see this, in free space let d is equal to 8xyz raised to 4 ax cap plus 4x square z raised to 4 ay cap plus 16x square yz cube az cap picocoulomb per meter square. Find, question A, total electric flux passing through the rectangular surface z is equal to 2, 0 less than x less than 2 and 1 less than y less than 3 in the az cap direction. The second question is find electric field intensity at p 2 minus 1 3. Find an approximate value for the total charge contained in an incremental sphere located at p 2 minus 1 3 and having a volume of 10 raised to minus 12 meter cube. Right. So first we'll see the first question, that is total electric flux passing through the rectangular surface z is equal to 2. So it is not for the entire this one. The flux passing through a surface is obtained by from according to Gauss law it will be closed integral d dot ds, and that will be charge enclosed, but here that is not the case. We have to only find the flux passing through the surface z is equal to 2, right. So z is equal to 2 surface will be like this, the z axis at 2 you have a surface. The limits for x and y are given. For x the limits are 0 to 2, okay, 0 to 2, and along y the limits are 1 to 3. So starting at 1 to 3, so this will be our origin. Okay, so 1 2 3, so z is equal to 2, that is the surface, so you have to see in this direction. So here ds is nothing but dx into dy into az cap, so you have to identify this one. So what we have to find is this one, so is equal to d dot dx dy az cap. So since this az cap is there, it is dot producted with the d, only the az cap component in the expression will remain, the remaining component will become 0. So what is left is 16x square yz cube. So at z is equal to 2, so z is equal to 2, 16x square y z cube dx dy will be left. What happened to the other terms in the expression? They are ax cap and ay cap direction. So if you find the dot product, that will become 0. Dot product will be 0. That much pico is there, into 10 raised to minus 12 is there. So so what you have to do is you have to substitute z is equal to 2. So it will be 16 into x square into y into 8 dx dy with the limits for x is, as we discussed here, it will be 0 to 2, and limits for y is 1 to 3, which is nothing but 128. 16 into 8 is 128. X square y, limit 0 to 2, 1 to 3 dx dy. Now we will integrate only x square dx first, so that will be 128 into 1 to 3. X square, it will be x cube by 3 with the limits 0 to 2 into y dy is equal to so 128 into 2 cube is 8, so 128 into 8 by 3 will be taken outside, so 0 by 3 is 0. Then integral y is y square by 2 with the limits 1 to 3, that is equal to 128 into 8 into by 3 into 3 square is 9 by 2 minus 1 square is 1 by 2. So again it will be 8 by 2 is 4. So if you calculate the value, you will get 1365.3 picocoulomb. So there is picocoulomb is there, so that much picocoulomb. So that is the answer for the question A. Okay, next question is find E at 2, minus 1, 3. So what is the relationship between D and E, vector D and vector E? Right, E is equal to D by epsilon. So D is equal to epsilon 0 E. So we know the value of D, so we have to divide it by epsilon 0 at a point at P 2, minus 1, 3. So we'll calculate first D at P 2, minus 1, 3. So P D, that is the expression is 8 D equal to 8x y z raised to 4 ax cap plus 4x square z raised to 4 ay cap plus 16x square y z cube az cap picocoulomb per meter square. So you have to substitute 2, minus 1 and 3 here, so that will be 8 into 2 into minus 1 into 3 raised to 4, that is 81. This will be 81 ax cap plus 4 into 2 square, that 4 into z raised to 4, that will be 81 ay cap plus 16 into 4 into minus 1 into 3 cube, that will be 27 az cap. So if you substitute the values, you will get 1296 ax cap plus 1000, this will be minus plus 1296 a y cap minus 1728 a z cap. So this is D. So we have to calculate E. So E will be D by epsilon 0. Here it is pico, so pico is there, 10 raised to minus 12 is there. So that will be minus 96 ax cap plus 1296 ay cap minus 1728 az cap into 10 raised to minus 12 divided by pico is there, right? 8 into epsilon 0, 8.854 into 10 raised to minus 12. So 10 raised to minus 12 cancels. So minus 1296 by 8.854 is minus 146.37 or 1.46.4 if you round ax cap plus 1296 is the same plus 146.4 ay cap plus minus 1728 by 8.85 will be 195.2 az cap. So pico is cancelled now, that much Newton per coulomb. So that is the answer. Okay, so that's about the part B of the question. Now the part C of the question is find an approximative value for the total charge contained in an incremental sphere located at P 2 minus 1 3 and having volume 10 raised to minus 12. So this is incremental volume of size 10 raised to minus 12. So delta V is given. So delta V is equal to 10 raised to minus 12. So what we have studied is divergence of D is equal to Q enclosed divided by delta V, as delta V tends to 0, right? So I can say that I have to calculate Q enclosed, so that will be divergence of D into delta V. So this is approximate because we have taken not delta V tends to 0, but we have some significant value of delta V. Delta V is not 0 here, right? So we will calculate the approximate value of charge by calculating divergence of D. So what is divergence of D? Dou dx by dou x plus dou dy by dou y plus dou dz by dou z into delta V equal to, now what is dx? 8xyz raised to 4. So dou by dou x of, this is the point also given, P 2 minus 1 3. Okay, so dou by dou x of 8 x y z raised to 4 plus dou by dou y of 4 x square z raised to 4 plus dou by dou z. Remember, when you take the divergence, there won't be any vector components, only scalar values. 16 x square y z raised to 3 into whole into delta V. So that will be 8 y z raised to 4 is a constant. The left is dou x by dou x, that will be 1 plus dou by dou y of 4x square z raised to 4. So we don't, everything is a constant, so derivative of constant will be 0 plus the third term has 16 x square y is a constant, only z is the variable, so into 3 z square. So 8y z raised to 4 plus 16x square y 3z square. Now we have to substitute the value into 10 raised to minus 12 at p2 minus 1 3. So that will be 8 into minus 1 into 3 raised to 4 is 81 plus 16 into 2 square, that is 4 into minus 1 into 3 into z square is 9. That much. So this will be in pico again, right? So there will be always d is in pico. So we have into 10 raised to minus 12 already there. So again it will be 10 raised to minus 12. So 10 raised to minus 24. So if you simplify this expression, you will get the value as minus 2.38 into 10 raised to minus 21 coulomb. So that is the charge enclosed in a small volume as the volume tends to 0. The next question is find the numerical value for divergence of D at a point specified. So you have to calculate D equal to 2 rho z square sin square phi a rho plus rho z square sin 2 phi a phi plus 2 rho square z sin square phi a z cap coulomb per meter square at p 2 comma 110 degree comma minus 1. So what we have to do, you have to find the value of del dot D. So we have seen the general equation for del dot D, right? What is that? 1 by h1 h2 h3 dou by dou u of h2 h3 du plus dou by dou v of h1 h3 dv plus dou by dou w of h1 h2 dw. So which coordinate system here? Rho phi z, right? So rho phi z means u v w are rho phi and z, and h1 h2 h3 are rho is a length, 1 phi is an angle, radius is a rho, omega w is z length, again 1 rho 1. So substituting, you will get del dot D is equal to 1 by, always do in this method, no need to by heart the general expression, because if you study this way or do the problems with these expressions, you will remember this equation also and it is easy for you. So 1 rho 1, so 1 by rho into dou by dou rho of h2 h3, that will be rho d rho plus dou by dou phi of h1 h3, so that will be 1 d phi plus dou by dou w of h1 h2, that will be rho into dw is dz, so dou by dou z dz, rho dz. Okay. So if you multiply 1 by rho inside, so that will be del dot D is equal to 1 by rho dou by dou rho of rho d rho. You cannot take rho outside because the differentiating parameter is dou rho, plus 1 by rho into dou by dou phi d phi, 1 by rho dou by dou phi of d phi, plus the next expression you have dou rho can be taken outside, so rho cancels, so dou by dou z dz, so that will be 1 by rho, what is d rho is this much, 2 rho z square sin square phi, So dou by dou rho into 2 rho 2 rho z square sin square phi, z square sin square phi, plus 1 by rho dou by dou phi. So phi is d phi is the second one, rho z square sin 2 phi. So rho z square sin 2 phi plus dou by dou z of dz. So dz is 2 rho square z sin square phi, rho 2 rho 2 rho square z sin square phi. Okay, so that will be 1 by rho into all the constant terms with respect to dou rho will be z square and sin square phi and 2. So 2 z square sin square phi can be taken outside. So the left is dou by dou rho of rho square plus 1 by rho. Here the constants are rho and z square. So rho z square can be 1 by rho z square can be taken outside, rho cancels, z square dou by dou phi of sin 2 phi plus here 2 rho square sin square phi can be outside, 2 rho square sin square phi it can be taken outside. So dou by dou z by dou z. Okay, that will be here 1 by rho 2 z square sin square phi into 2 rho, so rho cancels, plus z square sin 2 phi is 2 cos 2 phi plus 2 rho square sin square phi. Right, now you have to substitute the values of 2 1 0 minus 1 1 degree comma minus 1. So this is rho, this is phi, this is z. So substituting rho equal to 2, phi equal to 110 degree and z is equal to minus 1, z is equal to minus 1. So substituting this will be 2 into 1 into sine 2 into 2 4 into 1 into sine square of 110 degree plus z square 2z square. So 2 into 1 into minus 1 square is 1 cos 110 degree plus 2 into 2 square into sine square of 110 degree. So add all these values, you will get the value as 9.06. So del dot D is, as we discussed, it is unitless, so that value will be 9.06. So that's all for today's class. We will discuss about divergence theorem in the next class. That's all. Thank you.